All right, Mr. Trutna here, Clovis High School. We're going to go over Unit 11, Worksheet 3B. Once again, this is Mr. Trutna. This is Clovis High School, okay? And we're going to be using complex numbers. So what we're going to do is we're going to do number 1 and number 3. And in number 1 and number 3, we're going to be solving the following equations for x. And then we're going to express our answers as complex numbers in simplified radical form. So a couple things. When we get an answer in this problem, what we want to do is we want our answer, and it's going to be expressed as a complex number, and we're going to put it in simplified radical form, okay? So what does complex number mean? Remember, what that means is that there is a possibility that we are going to have an imaginary number in our answer, okay? And then in simplified radical form, what does that mean? This means that there are going to be no decimals allowed. So in other words, you're not going to be allowed to just type into your calculator the square root of some number and give the answer as a decimal, okay? So number 1, x squared plus 6x is equal to negative 13. Here's how we're going to do it. We're going to put a parentheses. We're going to put the x squared part, and we're going to put the plus 6x part inside the parentheses. We're going to leave a gap, and then we're going to close the parentheses. Then we're going to leave a space after the parentheses, and then we're going to write equals a negative 13. So what we're doing is we're going to use a process called completing the square. Okay, now, so inside this parentheses, we're going to complete this, and we're going to make a trinomial, and here's how we make the trinomial. We take that middle number, which is 6, which we call our b value. We're going to cut it in half, so we're going to divide it by 2. That's going to give me 3. And then we're going to multiply it by itself. And whatever that result is, which in this case is going to be positive 9, you're going to write inside this parentheses. And whatever you put inside the parentheses, you're going to put the opposite immediately outside the parentheses. So we're going to put a minus 9 outside the parentheses. All right, why do we do that? Well, the parentheses now is what we call a perfect square trinomial, and we got a plus 9 by doing this process right here. And then why did we put a minus 9 outside? Well, because what we had to do was we had to zero out whatever we put inside the parentheses. So positive 9 minus 9, those would zero each other out. Okay, so now we're going to factor this x squared plus 6x plus 9. Okay, in other words, we're going to complete the square. So how do we complete the square? Well, we know that we're going to get parentheses to the second power, and because this is a plus right here, our factor is going to be x plus, and then the unique number that's going to be for our factor is going to be half of that middle number. So to complete the square, you take half of that middle number and put it right here. So x squared plus 6x plus 9 will factor into quantity, or parentheses, x plus 3 to the second power, and then we put a minus 9, and then we put a equals negative 13. Okay, now we're going to solve this problem, and we're going to solve this problem out for x. So what does that mean when we solve for x? It means we need to get the variable x by itself on the left side of the equation. So my first step is I'm going to eliminate the minus 9. How do I do that? Well, I add 9 to both sides of the equation. So watch what happens when I add 9. Those 9s would cancel out, and then below this line I'm just going to write whatever my new equation is. So I'm going to get parentheses x plus 3, and then I'm going to get a second power, and then these 9s cancel each other out, and I get equals, and then negative 13 plus 9 is negative 4. Okay, now I have not isolated the x. I don't have x by itself, so next I need to get rid of that power of 2. So what do I do to get rid of the power of 2? Watch this. I'm going to take the square root of both sides. Okay, why do I do that? Well, because the opposite math operation of a second power is a square root, so those two will cancel each other out. And you can see now what I have left in my equation is x plus 3 is equal to, and then I have the square root of negative 4. So what I'm going to do is I'm just going to write that equation over here, give me a little bit more room to work this out. So I have x plus 3 is equal to negative 4, and a square root of negative 4, excuse me. And now I'm going to solve this out. Okay, so what I have to do is I have to express this in simplified radical form. So how do I find the square root of negative 4? Well, what you do, if you recall, is you're just going to rewrite the square root of negative 4 as the square root of positive 4 times the square root of negative 1. Why can we do that? Well, because 4 times negative 1 is negative 4. Okay, well, what's the square root of 4? Well, that's positive or negative 2 times, and what's the square root of negative 1? That is I, the imaginary number. Remember, by definition, I is equal to the square root of negative 1. So anytime you see a square root of negative 1, and we have it right here, we're just going to replace that with the imaginary number, which we denote as I. So that, when I write this out, I'm going to get x plus 3, that's still in my equation, is equal to, and the square root of negative 4 became plus or minus 2i. Okay, plus or minus 2 times I is just plus or minus 2i. All right, now I'm not done. I'm getting close to it. Now my last step in this case is I'm now going to subtract 3 from both sides of the equation. So when that happens, notice those 3's cancel each other out. And then if you notice, if I bring down my equal sign, the only thing to the left of my equal sign is x. So I'm about to find out what x is equal to. Okay, so how do I do this? I have plus 2i, I have minus 2i, and I'm going to minus 3. All right, so what I do is I ask myself, I go, all right, can I subtract 3 from 2i? No, those are totally different. Can I subtract 3 from negative 2i? No. So my answer is plus or minus 2i minus 3. That's what x is equal to. This is the best that I can do to get this answer right here. Okay, so let's see. Did I express my answer? Yes, I have x equals. Is it a complex number, an imaginary number? Yes, it is. Is it in simplified radical form? Yes, it is. So that would be an acceptable answer for number 1.Moving on to number 3, I'm going to solve this the same exact method as I did number 1. So I'm going to start with parentheses. I'm going to put the x squared. I'm going to put the minus 2x inside of parentheses. I'm going to leave a little bit of a gap before I close the parentheses. And now in this case, I'm going to put a plus 10 outside the parentheses. Then I'm going to leave a little bit of space, and then I'm going to write equals 0. Okay, so if you notice in number 3, when I started the problem, I had to start with the plus 10 outside the parentheses, and that's because in this problem I had this c value. So I start outside. Notice in number 1 there was no c value, so there was no number to start outside the parentheses, if you recall. Okay, so now what I'm going to do is I'm going to fill out this parentheses. So I'm going to make a perfect square trinomial. And the way that I do that is I take this term right here in front of the x, the coefficient in front of the x, which is negative 2. I cut it in half by dividing by 2. That's negative 1, and then I multiply it by itself. And the result I put right here. Negative 1 times negative 1 is positive 1. Then remember, we have to zero out. After we make this perfect square trinomial, whatever we put inside the parentheses, outside the parentheses, we have to put the opposite of positive 1, which in this case is negative 1. Now I'm going to take this parentheses right here, which is called a perfect square trinomial, and I'm going to factor it. It's going to factor into 2 binomials, but the binomials are going to be the same thing. I'm going to have an x, because that's a minus there. I'm going to have a minus, and then my unique number for my factor is I'm going to take the middle term, take half of it, and put it here. What's half of 2? 1. So this becomes x minus 1 to the second power. Now I'm just going to simplify. Positive 10 minus 1, that's positive 9, equals 0. Okay, so this process right here is called completing the square. That's what we're doing in number 3, as we did in number 1. Now I'm going to take my steps to solve this problem. So I need to solve for x. So remember, my first step is, in this case, I'm going to subtract 9 from both sides of the equation. That would cancel out those 9's, and then underneath this line I'm just going to write what my new equation becomes. I'm going to start systematically eliminating numerals. Okay, in this case I eliminated the plus 9, and now I get x minus 1 in parentheses to the second power, and then 0 minus 9 makes this equal to negative 9. Now I would like to get rid of that power of 2. So what's the opposite math operation of the power of 2? It's the square root. So you're going to square root both sides of the equation. Why do I do that? Well, because remember, this power of 2 is going to cancel out this square root symbol. So then I get x minus 1 is equal to, and then I'm going to get the square root of negative 9. Now once again, I'm just going to go over here and I'm just going to rewrite that so I have a little bit of more room to work this out. Now, all right, so the square root of negative 9. So now I have to simplify that. All right, so how do we simplify that? So remember, I'm going to simplify the square root of 9 into breaking it up into the square root of positive 9 times the square root of negative 1, and then I'm going to simplify both of these. What's the square root of 9? Well, that's positive and negative 3. Why is it? Because 3 times 3 is 9, and negative 3 times negative 3 is 9. So I get positive and negative 9 times, what's the square root of negative 1? Remember, by definition, anytime you see a square root of negative 1, you turn it into I. So this would become, my equation now would become x minus 1 is equal to positive or negative 3i. 3 times I, positive or negative, becomes positive or negative 3i. Now I'm going to add 1 to both sides of the equation. And if you notice, those 1's would cancel out. I bring down my equal sign, and the only thing to the left of the equal sign is x. So I'm about to solve for x. Okay, so now I go over here. Can you add 1 to 3i? No. Can you add 1 to negative 3i? No. Remember, you can only add or subtract like terms. So my answer is plus or minus 3i plus 1. And that's the best that I can do in number 3. But that would be my solution for number 3. Okay? All right, so then I'm going to turn it over. You did not have to do number 5 or number 7 yet. But I'm going to turn it over, and I asked you to do on the back side number 10 and 12 and 16 and 18. So we're going to do number 10, we're going to do number 12, we're going to do number 16, we're going to do number 18. Okay, so number 10, we have the quantity 7 plus 3i, and then we're subtracting from it the quantity 5 minus 8i. So remember, whenever we're subtracting and parentheses are involved, we want to rewrite the problem without parentheses. So how do you rewrite the problem without parentheses? Well, you take whatever number is in front of the parentheses and you distribute it. So in front of the 7 plus I parentheses, there's a 1. So I'm going to distribute the 1. So I'm going to go 1 times 7, and then I'm going to go 1 times positive 3i. So when I do that, I get 7 plus 3i, and the distributed property allows me to rewrite the problem without parentheses. Then when I get to the other parentheses, the 5 minus 8i parentheses part, I'm going to distribute this minus 1 here. So what's minus 1 times 5? Well, that would be negative 5. What's negative 1 or minus 1 times, and you got to be careful here, that's a negative 8i, that would be positive 8i. So rewriting the problem without parentheses, I get 7 plus 3i minus 5 plus 8i. Now, to finish off my problem, I'm going to combine like terms. So let's start with the 7. Is 3i like with 7? No, I can't combine those. Is, whoops, lost the lights for a second. Sorry, all right, lights are back on. Is minus 5 like with 7? Yes, they are. I can combine those. So what is 7 minus 5? Well, those combine to make 2. Okay, now let's combine the i's. Positive 3i, I can combine with positive 8i. So what's positive 3i plus positive 8i? That would be a positive 11i. And there's your answer to number 10. You cannot simplify that problem anymore. All right, number 12, we have quantity 5i to the second power. Okay, so what does that mean? So remember, this second power means you have to take the 5i, you have to take whatever is below it. Whatever's below an exponent is called the base, and you're going to multiply it by itself 2 times. So why do you have to multiply 5i times 5i twice? Because that power is 2. 5i is the base. Okay, so how do I multiply these? Well, remember, when you multiply, you're going to multiply the coefficients, the 5 times the 5, that is 25. And then you're going to take the i's, which both have an exponent of 1, and you're going to multiply them. But you add the exponent. So I to the first times I to the first becomes I to the second. Why to the second? Because 1 plus 1 is 2. Okay, and that's your answer, unless you can simplify it. But we can, because if you recall, anytime you see an I squared becomes negative 1. Okay, that's the rule of the i's. Okay, so then 25 times negative 1 is equal to 25. So number 12 would become negative 25. Okay, moving on to number 16, we're taking the binomial, the quantity 6 plus 4i, we're multiplying it by the binomial, the quantity 5 minus 2i. So number 16 is a multiplication problem. So what we're going to do is we're going to draw the rectangle. All right, so the rectangle is a visual to help you on how do you multiply binomials times each other. So along the top of the rectangle, you write the first, whatever's in the first parentheses, the first binomial, 6 plus 4i, and at the plus sign, you're going to draw a line and divide the rectangle into two rectangles. Then along the left side of the rectangle, you're going to write what's in the second parentheses, 5 minus 2i, and at the subtraction symbol, you're going to draw a line. So what you're going to do is you're going to divide this rectangle into four rectangles. And then you're going to find the area of each one of these rectangles, and then you're going to add up whatever's like to get your final solution. Okay, so the top left rectangle, you're going to go 5 times 6, so that's 30. The top right rectangle, you're going to go 5 times 4i, which is 20i. Okay, the bottom left rectangle, you're going to go this side. You've got to be careful. It's a 2i, but it's a minus 2i. So you're going to go minus 2i times that side, which we already said was 6. So that's a minus 12i. And then the bottom right rectangle, you're going to go this side, which we said was minus 2i. You're going to multiply it by this side, which is positive 4i. And that's going to be negative 8i squared. Okay, but what do we turn I squared into? Negative 1. So this would become negative 8 times negative 1, which would give me positive 8. Okay, so what we're saying is that and that, the 30 and the 20i and the minus 12i and the 8, when I add these all up, that is my answer to my problem. So this is equal to 30 plus 20i plus negative 12i plus 8. And that's going to be your answer unless you can simplify it. So is there anything we can combine together? Absolutely. I can combine the 30 with the positive 8. That's going to give me 38. I can combine the positive 20i with the negative 12i. That would give me positive 8i. So my solution to number 16 is 38 plus 8i. Okay, moving on to number 18, I have the quantity 2 plus 7i to the second power, so we have an exponent. So remember that 2, that exponent of 2 is saying take whatever is below it and multiply it by itself 2 times. So this problem translates to 2 plus 7i times itself 2 plus 7i. And it's very important that you know that's what that second power means there. Now, how do we multiply 2 plus 7i times 2 plus 7i? We're going to use the rectangle method. So we're going to use, some teachers call this the FOIL method. Don't worry about what that means. We're not going to talk about that in this class. The only time we'll use FOIL in this class is when we're wrapping up food after we're done eating it and we want to take it home. Bad joke, sorry. So along the top of the rectangle, I'm going to write 2 plus 7i. What's inside the first parentheses? At the plus symbol, I'm going to draw a line, dividing this big rectangle into two smaller rectangles. Then I'm going to write 2 plus 7i, what's along the second parentheses, okay, along this side, and at the plus symbol, I'm going to draw a line, so I'm going to divide this rectangle into 4 separate rectangles. Then remember, the idea is I'm going to find the area of each separate rectangle, and then my answer is going to be all of the areas added up. So the top left rectangle, 2 times 2, that's going to give me 4. The top right rectangle, I'm going to take this side, which is 2, multiply it by this side, which is positive 7i. 2 times 7i is 14i. Then to get the bottom left rectangle, I'm going to take this side, which is positive 7i, and then I'm going to multiply it by this side, which we said was 2. That's going to give me 14i, 7i times 2, 14i. Then to get the bottom right rectangle, I'm going to take this side, which is 7i, I'm going to multiply it by this side, which is positive 7i. So what's 7i times 7i? Well, that's 49i squared. But remember, I squared, by definition, always becomes negative 1. So this becomes 49 times negative 1, so that gives me negative 49. So my answer is 4 plus 14i plus 14i plus negative 49. Okay, and that would be my answer if I can't simplify it at all. Well, can we simplify it? Absolutely. So what can I combine with the 4? I can combine the plus negative 49. So what's 4 plus negative 49? That's negative 45. And then I can combine the positive 14i with the positive 14i. That's going to give me positive 28i, and that would be my solution to number 16. Okay, so those were the problems that were assigned on worksheet 5B on the second day. Okay, come to class if you have any questions.